Today, we're going to be able to identify and interpret the rate of change in initial value from a graph and write the equation of that graph. You've already learned how to find the slope and y-intercept, but we're going to interpret them in context, and there are some differences for when you have a graph in context for how you figure out the slope. So we're going to talk a little bit about that. So first thing that you should notice is you should find out what x equals and y equals. You're going to look at your axes to do this. Basically, your axes are your friend on this. Those big lines tell you not only what everything represents, but how big everything is going to get. So you're going to want to pay very super close attention to the axes. You should always be looking back at them. So when we look at this, we find that our x value is time at the state fair in hours, and then money in Trisha's pocket. And if you were to just look at this, you'd say, well, it looks like as she spends more time at the state fair, her money goes down, and it looks like she spends all of it. So we're going to go over and we're going to say x equals time in hours, and y equals the amount of money in her pocket. Now, when we write this, this is always going to be a number. So x will be a number of hours, and then y will be the amount of money. Then you're going to I would identify the initial value first because it's easiest to tell. Remember that initial value is another word for y-intercept. But it gives us a clue that that's the starting value. So our initial value here is 25. I'm going to write it as a point. It's 0 is my x value and 25 is my y value. And we can just, to interpret this, we can just put the x and y values that we found up here into a sentence. So at 0, and that was hours, she has 25, and what was the y value? $. So basically, when she arrives at the state fair, she has $25 in her pocket. Then we're going to go ahead and find the rate of change. Now, the rate of change, it is synonymous with the slope. However, we're going to find it just a little bit differently than before. Because you could have any numbers along the side in the situation, you are not going to count the squares when you find the slope. To find it, you're still going to find change in y over change in x, and you're still going to draw a triangle with pretty points. This is the part that changes, though. On this one, these are going to be the same, but you're going to have to pay careful attention to your axes. Remember how I told you your axes are super important and you always look to them? We have to make sure that our change is the actual number that we say it is. So I'm going to look at my axes, and when I look at this, it's going down, and it's going from 25 to 15, so it's going down 10. On this one, it's going up from 0 to 5, so it's going up 5. Do not count the squares because a lot of the time, probably at least 50% of the time, if you count the squares, you will get the answer wrong. So look at your axes to figure out how far it goes over, and it may be that you have a point right there, and you have to figure out what that point is. We're going to do an example where we might have to be a little more careful with what those measurements are. So I'm going to go ahead and put my rate of change into a fraction. It's change in y over change in x. And remember, this change in y is the y quantity. So it's not how many squares, it is how much that y quantity changes. So you have to look at the numbers. Negative 10 over 5. And when I divide that, a negative divided by a positive is a negative, and it is 2. So this is always going to end up being your y value per x value because we had y on the top. So I'm going to have my y value per my x value, and my y value, let's look at what I did in step 1, is $, and then it's per hour. So this is our y per x. So it's going down negative $2 per hour. What does that mean for Trisha? Well, so negative means it's going down, and we're talking about money. So she's losing $2 per hour. Anytime you get a negative number, you're going to have to say what that means. It's usually losing, going down, some sort of thing like that. Okay, your last step is to write your equation and use that to interpret any other questions they might ask. So our equation will be y equals mx plus b, and we're going to put the numbers that we found in for m and x. So we had our number that we found, m and b, excuse me. So our number that we found for m is in step 3, that's -2. So I'm going to put y equals -2x, and then my number that I found for b was 25. Now, they could ask you potentially any question about what's going on in this graph. You could look at the graph, or you can use this equation now. So if they were to ask you, how much money does she have in her pocket after 2 hours? I'm going to write that down. So after 2 hours, how much money does she have? I didn't write the whole question, sorry. So we're going to look at our x and y equals. We said x was hours, so that means I'm going to put 2 in for my number for x. Y equals -2 times 2 plus 25. Then how much money she has is whatever you get when you plug this in your calculator or when you figure it out. This is -4 plus 25, so that's 21. That means after 2 hours, she has $21. And you could even find that on the graph. When you go to 2, 21 is right there. So you can find that from either the equation now or the graph. Okay, we're going to go ahead and do these steps real quickly with this example, the money in Laura's bank account. This one is going to be a little weird. So we notice that our X is weeks since Laura Kate's birthday. And then our Y is going to be the money that she has. Okay, so now let's look at our y-intercept. This one's a little weird. This graph is a little wonky, like the scale doesn't start at 0. This is not 0. I don't know what that is. But the y-intercept is at this point. So on the x-axis, it is 0, and it's going to be 0 to 100. So our b equals 200. Then to find our rate of change, we need 2 pretty points. Why not use that one? And then I'm going to use this one. So now I have my slope triangle. This is where I was saying that you should be careful. If you were to count these squares, you would say that it goes up 15 over 1 square. Let's actually be careful and let's look at this. It goes up from 200 to 30. So it's going up 30. And then it's going right 1 square out of 5 squares. 1 square out of 5 squares, and it goes to 10. So that means that this is going 2. So our m is going to be 30 over 2, or 15. Now let's go ahead and interpret those. That 200 means that she has $200. It says 0 weeks after her birthday, so on her birthday. And that 15, remember we're going to do 15y per x because it's change in y over change in x, that's y. So my y is going to be, what was it? Money, so dollars, $15 per week. And it is positive, so that means she earns $15 per week. Okay, then we're going to write our equation, and if it were to ask you any question of x versus y, then you can answer it using your equation. I'm sorry, my work looks a little ugly here, but y equals mx plus b. I'm going to put y equals, and my m was 15, and my b was 200. So now, if I were to ask you, okay, when will she get $500? Okay, let's look at our quantities. Dollars was the y quantity. So I'm going to put in 500 for my y. And then solve for x, and that will tell me when she'll have $500. So I'm going to go ahead and make my equation. I undo addition first. Okay, and then we're going to divide by 15 to find out what x equals. And 300 divided by 15 is 20. You can put that in your calculator too. So x equals 20. 20 what? Is it 20 days? Is it 20 years? Because that would be lame. Look at your quantity. It's number of weeks. So after 20 weeks. And it was 20 weeks since her birthday. So basically what you're doing this entire time as you're interpreting is you're referring back to what x and y are. And when you find your slope, it's super, super important that you look at the numbers on the sides and you find the difference between those numbers on the sides. Like on here, we knew it went from 200 to 230, so we knew it went up 30. On this square over here, we had to do a little bit of math. We had to find 1/5 or 10 divided by 5 to figure out what that square was. All right, hopefully that helps you out. Good luck.